Okay, so not entirely sure how well the audio is going to be able to pick up given the sound of the river at the moment, but this is the same river that I've shown you earlier on when I've explained the formation of meanders, and this is sort of perhaps showing better now, more than any other time, why the meanders actually form. So if you look sort of towards the distance over here, you can see where the white water is. So we can actually see what's called the thalweg, and that is the fastest area of water that's moving. And generally that's in line with where the deepest part of the rivers is. So the higher the speed, the more erosional capacity the water's got, which makes the river deeper, which reduces the amount of friction between the water and the riverbed, allowing it to flow faster. So it's almost like a self-fulfilling cycle, a bit like a positive feedback loop. So you can see on the far side here that as it's hitting the outside of the meander, that's where the fast water is, and it almost bounces in a straight line coming down to here, where we have our next meander bend. Now,
okay, apologies for the video cutting off. A large droplet of water actually landed on my screen and turned off my recording without me realising. So what I then go on to explain is how this leads to the diagram that you can now see on the board. So where the label is for the fastest current on the right hand side, this is the thalweg that I was talking about in the video. So that is where the fastest water is, and this cross section shows how the water is deeper at that section, and therefore the water's got more energy. So we're going to get a lot of erosion on the outside banks, and that's led to the river cliff that you can see is next to the label Y. And whilst this is happening on the inside of the bend, something that I didn't really talk about within the video, where there isn't white water, well, the water that's there is much shallower, so there's a lot more friction with the bed, and that means that we've got a much slower current and the water has less energy, and that causes it to deposit its load. So on the inside of the bend, we tend to get what's called a slip-off slope, which is almost like a beach forming. And over time, these two processes combine, and that allows the river to migrate, so to move, and it means that it's constantly going to move, in this case in the diagram, in the direction of Y. And if those meanders keep bending and the outside bends keep getting bendier and bendier and bendier, that's when the river will have a narrow neck, that during a time of flood the neck will be cut off, and we will eventually see the formation of an oxbow lake. Okay, so the next thing that I wanted to revise with you was about the causes of flooding. So when I showed you that video, it was during a time where the river was in flood. It had actually burst its banks. I know it wasn't obvious from the video, but it was significantly higher than it was in the photo that I showed you at the start of this video. Now, the reason this happened is because of the weather conditions and what had been happening in the surrounding area of that river. So just as a little bit of a reminder, or to inform you in case you don't remember, on Friday we'd had a period of quite heavy snowfall, not enough to close school, but it still meant at the tops of the hills and the area around where I was had a significant quantity of snow. So that happened on Friday. On the Saturday, we had much warmer temperatures, which caused the snow and the ice to melt. Now, this meant that all of that water, all the precipitation that had been stored in snow, was melted and released at the same time. So you had hours and hours and hours worth of precipitation all making its way downhill into the river. And to make things worse, the ground was still frozen, so that water couldn't infiltrate into the soil and move slowly. Instead, it was moving by surface runoff, which is far quicker, and it meant that the water arrived into the river at the same time, which caused it to go into a flood. In addition to that, on the Saturday, we also had torrential rain, so very heavy precipitation, and that added a lot more water again into the river, causing it to burst its banks. The final thing that had occurred is that in this area they're currently, and slightly ironically, building some flood defences, and as part of that they've cut down all the trees in the area so they can get the vehicles in and out. And what that means is that with deforestation we get reduced rates of interception. So when we have leaves, the rain droplets get caught on the leaves of the trees, and that slows down the rate at which the water can enter the river. Now, because those trees weren't there, again, it means that all of that precipitation was moving by surface runoff into the river, and the faster the water gets into the river, the far higher the chance is that you're going to experience a flood.